Hello students, in the last video we looked at the derivation for the equation that describes the lens, and as it turns out, it turned out to be the equation of a sideways parabola involving something that's called a focus and a directrix. So what we're going to do in this video is we are going to develop the equation for a lens that's oriented not in this position but in another position. So, or as we would like to traditionally, like to know it, it's a parabola oriented vertically, right? Which is how we all studied, how we all had studied parabolas in the very, very beginning. So again, but we are going to look at how we can write the equation of a parabola with the context of this idea of a focus and a directrix. So in the last video, we are going to capitalize on the fact that the path, the length of the light, okay, traveling from the directrix to the focus, okay, that they are going to be equal, and in particular, this very special distance we're going to call P. Okay, and this apex of the lens there, we're going to call we know that to be the vertex. We're going to call that point there h comma k. And again, this is graphed on a coordinate grid. Okay, so we'll have a set of coordinates. This again is going to be our focus. Our focus, okay, with reference to the vertex, will be p units above the vertex, which means it will have coordinates of h comma k plus p. And all the distances, okay, for the path of the light within the lens, and then from the path of from the lens to the focus, okay, those are supposed to be the same. Let me try to do that one more time. So these lengths right here are supposed to be the same length, drawn to the best of my abilities. Okay, and we're calling this D1 and we're calling that D2, and this point right there on the lens, we're calling that X comma Y, because it's just some point on the lens. And what's different about this situation from the last scenario is here now D1 is a vertical line, okay, D2 is again a slanted line, but it is a vertical line. It is the path from x comma y to the horizontal line, which is our directrix. So the length of the, or not the length, the equation describes the directrix, okay? The directrix is p units beneath our vertex. So it is a, it is vertically, okay, there's a difference of p happening here. So we're going to take the difference of the y coordinates. To describe the equation of a horizontal line, we always write it as y equal to some number, right? So what exactly is that? It's y equals to k minus p. This is the equation for the directrix. We are going to be using this. Okay. Our focus, one more time, is this. Now we're going to come up with equations describing D1 and D2. So D1 is equal to, well, it's just a vertical line. We're going to take the coordinate x comma y, and we're going to find a distance between x comma y from the directrix. Well, that's just the difference in the y coordinates. So it's y minus k minus p. We're going to do this again for D2. So we're going to take the focus, the coordinate x comma y, which is a point on the lens, okay, and find the distance between that and the focus. So that will be square root of, again, I'm going to find a difference of x, so it's x minus h quantity squared plus y minus quantity of k plus p quantity squared. And again, we are going to capitalize on this fact of how the light is bent, and that those lengths, okay, are going to be the same. So what we're going to do is we are going to take D1 and D2 and we're going to set them equal to one another. So we're going to say we're going to take this and we are going to set them equal to one another. Very similar to part 1, okay, of the lesson. And this is where we are going to begin working on the equation and try to come up with an equation for the lens. So unlike the last video where we isolated x, here we are going to isolate y. Okay, we're going to isolate y. So and at the end, okay, what we're going to try to do is we're going to try to come up with a function that is y as a function of x. Okay, so what we're going to do, we're going to try to isolate y. What will happen is all of this on the left-hand side, whoops, will get squared, and then the part involving a square root on the right-hand side, there won't be a square root there anymore, so that will go away, and on the left-hand side, we are just going to square it. On the left-hand side, what we're going to do is we are going to try to FOIL this using structure. So this is y squared minus 2 times y times k minus p plus k minus p quantity squared. And on the right-hand side, we have very similar things. And I'm strategically, just like last time, I'm strategically choosing not to FOIL x minus h, because my goal is to not come up with the equation as x equal to something, but instead as y equal to something. So it doesn't matter whether I work with x or not. So I'm choosing not to FOIL that out. So this is going to be, on the right-hand side, I'm left with y squared minus 2 times y times k plus p plus k plus p squared. And just like in the last video, things will start to disappear because we have the same things on either side. And if you notice, again, the 2y, or yeah, the negative 2y, I'm going to distribute those in, so you're going to see more things begin to cancel. So what I'll end up with is negative 2yk plus 2yp plus k minus p quantity squared is equal to x minus h quantity squared minus 2yk minus 2yp plus k plus p squared. And what I'm going to do now is, if you notice again, the 2yk's, they cancel. I'm going to subtract over the 2yp's. So these 2yp's I am going to subtract over. And what I'm going to do is I am going to then also subtract over the these terms over here to the other side. And what I will end up with as a result is I'll end up with k minus p quantity squared plus k plus p, minus k plus p quantity squared minus x minus h quantity squared is equal to negative 4yp. And then from here, what I'm going to do is I am going to FOIL out the k minus p and the k plus p, because there are going to be terms that we can eliminate. So that's k squared minus 2kp plus p squared minus k squared plus 2kp plus p squared. And again, I'm strategically choosing not to FOIL out x minus h quantity squared. Now I'm going to eliminate. If you notice that these k squares will cancel, the p squares will cancel, and I can combine the negative 2kp to make negative 4kp minus x minus h quantity squared is equal to negative 4yp. What I'm going to do now is divide over negative 4yp from both sides, and if I do, I'll end up with k plus 1 over 4p times x minus h squared is equal to y, or y is simply 1/4 p x minus h quantity squared plus k. This is the equation. This is the equation of a vertically oriented parabola involving focus directrix. And if I may, maybe just to take another like 10 seconds to ask you guys to make a comparison, do you guys see similarity between this equation and this equation? I hope you do, right? Because if you look at this, this is just the equation of a parabola in vertex form. The only difference is this leading coefficient a, okay, as it turns out, has a lot to do with not only like of whether or not it's right side up or upside down, or you know, how much stretching vertically or compression it has, but also it tells us information about where the directrix and focus is going to be situated, and more to come, okay, about that as far as how we can analyze parabolas to determine the focus and directrix. Here is everything in its entirety one more time.